everyone, I'm Ava. Today we're going to be looking at the AMC 8 2024 problem set. So question 1 asks us, what is the ones digit of this equation? So this is a relatively simple problem. What you can do is you can calculate the ones digit for each of the adjacent calculations, and then based upon that, you can just keep going on. So for example, the first two, the ones digit comes down to 0, and then when you minus 2 again, it comes down to 8, and so on. You can continue that pattern on until you reach the final answer, which is a ones digit of 2. So we know that the answer should be B. Question 2. What is the value of this expression in decimal form? So it gives us this very complicated fraction addition problem, and we know that because this is only problem 2, we know that the numbers should be relatively simple, so we're confident that if we can just calculate this by normal fraction addition patterns, it should come out to a number that isn't too hard to calculate. So we can go ahead and do that. Then you get 44 times 400. If we take the denominator to be 4,400, then we have that, and then 110 times 100, and 44 times 4. So when you calculate that all together, you can first, before going ahead and multiplying everything out, you can divide 4 from the top and the bottom. So we get 11 times 400, and 110 times 25, and then 44 times 1 over 1,100. So we can add that up, and first we would get this number, and then 2750 plus 44 divided by 1,100. So when we add all of those numbers up together, we know that the numerator is 7,194 divided by 1,100. And we can perform some long form division, and we would get this result. Okay, excuse my bad handwriting, but eventually you would come down to this decimal number, which is 6.54. And when you're doing this in the actual competition, you can do this relatively quickly. So we know the answer is C, which is 6.54. Problem 3 tells us that there are 4 squares of these side lengths, and they're arranged in increasing size order so that their left edges and bottom edges align. The squares alternate in color, white, gray, white, gray, white, gray. And what is the area of the visible gray region in square units? So the first step is we know it's squares, so we can express this in the following way. It would be 10 squared minus 9 squared, and that would calculate this first region, the outer edge gray area. And then that added on to 7 squared minus 4 squared, which would calculate the second gray area, this area. And so simply we can just calculate these squares and then subtract them to get the final answer. So 10 squared is 100 minus 81 plus 49 minus 16. And that gets us 19 plus 33, which is 52. So we know that the final answer of this problem is E, 52. Problem 4. When Yoonji adds up all the integers from 1 to 9, she mistakenly left out a number. Her incorrect sum turned out to be a square number. What number did Yoonji leave out? So notice a trick here is, we know this is only problem 4, so obviously we don't need to go through every single number from 1 to 9 and check which one would lead to a square number. So a trick here, we can just first add up all the numbers from 1 to 9, and we can first observe what number do we get. So based off arithmetic sequence, the first number plus the last number divided by 2, and then times the number of numbers you get. So that would be 10 divided by 2 times 9, which is 45. And so we know the total sum is 45, which means that the minimum number that you could get in this case would be 45 minus 9, since 9 is the largest number, and that would get you 36. Now notice that between 36 and 45, there are no other square numbers. So know that the nearest square is 36. And so we get the answer is that the number that was left out was number 9. So the answer is E, which is 9. Problem 5. Alaya wrote a standard rows 2 standard 6-sided die. She noticed that the product of the two numbers rolled is a multiple of 6. Which of the following integers cannot be the sum of the two numbers rolled? So for a number to be a product, like a multiple of 6, it has the factors of 2 and 3. So we can write out that the possible combinations to form this product would be 2, 3, and 6 plus any number n, which would be like from 1 to 6, right? 1, 2, 3, all the way to 6 could be a possible number for that combination. And so the sum of 2 and 3 is 5, and the sum of 6 plus this random number n, we know would range from 7, 8, all the way to 12, since 12 is like 6 plus 6, right? So we can go back to our selections of answers and see. So 5 obviously is not correct. 7, 8, 9 are also all not correct. So we know that the final answer is B. Problem 6. There's this ice rink with different paths, P, Q, R, and S, shown by the gray lines. What is the sorted order of the 4 paths from shortest to longest? So first let's do some observation. We noticed that a lot of these paths, they have common sides, which are from on the left and the right sides. For example, P and R both have this. And then some of these paths both have this semicircle on the top and the bottom. So what we can do here right now is if we do some just pure observation, you know that the path R is definitely smaller than path P, since a semicircle is the longest length that you could have in that region. So we would write that down first. And next, we look at path P, Q, and S. Path Q, if you imagine that this part was reflected across that way, then it would form this hypotenuse of that triangle, which we know is longer than this diagonal. For example, this diagonal would be longer than this diagonal. So we get another thing, which is S less than Q. So now we just have to compare P and S and see which one is longer and which one is shorter. So you have P here and you have S here. Now obviously we know diagonals are longer than straight lines, so we can put that as well. Yeah, so this is the final answer, which is R, P, S, Q in the order of shortest to longest. So finally the answer we get is D. And yeah, this is purely just observation, and you don't actually need to calculate anything. Problem 7. 3 times 7 rectangle is covered by overlap of without overlap by 3 shapes of tiles. What is the minimum possible number of 1 times 1 tiles used? So for these types of problems, basically just try and maximize the using of larger tiles. For example, in this case, we'd want to maximize the number of 2 times 2 tiles that we would want to use. And we notice that 2 times 2 tiles can only be placed in they can only be placed within this region, since they're limited by the size and dimensions of the shape. So first we would just put as many as possible as we can, and then we would use the remaining 1 times 4 to fill in these gaps. And so then we come to here and we realize we can't place any more other tiles. So the final answer is E, which is 5. Problem 8 tells us that on Monday, Tay had $2. Every day he either gains 3 or doubles the amount of money he had on the previous day. How many different dollar amounts could Tay have on Thursday, which is 3 days later? So when you're given these 2 choices, because there's not that many choices, we can just use a tree, a probability tree, where you would start on this day and then you would go and keep going on until you have a certain number of possibilities, as shown above. So we can start here on day 1, and he has 4 days. So we start on day 1 where he has $2, and then next he has 2 possible ways he could go. Either he would add $3, in which he would get 5, or he would double the amount of money that he has, when he would get 4. So we continue that pattern on. Add 3, which is 8, double is 10, and then add 3 is 11, double is 16, add 3 is 13, double is 20. Add 3 is 7, double is 8, add 3 is 10, double is 14, add 3 is 11, and double is 16. So notice here that there are a few overlaps. For example, you have an overlap of 11 and 16 and 11 and 16. So we just write everything out in like ascending order to make sure we don't have any overlaps. So eventually you would come up to like this list, and if you just do some like counting, it's 6 different possible choices. So the answer is D. Problem 9. All the marbles in Maria's collection are red, green, or blue. Maria has half as many red marbles as green marbles, and twice as many blue marbles as green marbles. Which of the following could be the total number of marbles in Maria's collection? So we can set some variables first. Be careful here of the wording of what they're saying, but first let's see like green and red. Maria has half as many red marbles as green marbles, which means Maria has less red marbles, right? So that means that green equals 2R. And next is blue. She has twice as many blue marbles as green marbles, so B equals 2G, which if we bring in the red, we get 4R. So let's add everything up and describe everything as R. So you would have R, 2R, and 4R. And that adds up to 7R, so we know like the multiple, the final answer has to be a multiple of 7. We come here and we can select E, since that's the only multiple of 7 that we can see in the answers. Problem 10. In January 1980, the Mauna Loa observation recorded carbon dioxide levels of 338 ppm. Over the years, the average CO2 reading has increased by about 1.515 ppm per year. What is the expected ppm levels in January 2030? And it tells us to round. So this is basically just like an addition problem. It's like a word problem where you just have to convert it into an addition equation. So we start at 338. And then between 1980 and 2030. So 2030 minus 1980 times 1.515, which is the increase per year. And that gets us 338 plus 50 times 1.515. So we get 338 plus, we can multiply first by 5 and then multiply by 10 next. And then come back here at 75.175. And then we can add that value onto originally how many it had in the first year. And the final answer is 413.75. When we round that up to the nearest integer, we get the answer B, which is 414. Okay, problem 11. The coordinates of ABC are 5, 7, 11, 7, and 3y. The area of ABC is 12, and what is the value of y? Basically, the area of this total shape is 12. And recall that like we're given the base here already, which is 11 minus 5 is 6. And to calculate the area of a triangle, all you have to do is multiply base times height. So we can pull out the base here and pull out the height here to the left. And so we have the equation, which is height times 6 divided by 2 equals to 12. So height times 6 equals 24, and height equals 4. So now that we know the height is 4, we can know that y equals 7 plus 4, which is 11. So the final answer that we get is D, which is 11. Problem 12. Rohan keeps 90 guppies in 4 fish tanks. There's like 1 more guppy in the second tank than in the first tank, 2 more guppies in the third tank than there's in the second tank, and 3 more guppies in the fourth tank than there is in the third tank. So why don't we label like the number of guppies in the first tank as x? So we get x plus 1 plus x plus 3 plus x plus 6 equals 90. And when we collect all the terms, we get 4x plus 10 equals 90. So 4x equals 80, x equals 20, and x plus 6 equals 26. So the final answer is E, which is 26. Problem 13. Buzz Bunny is hopping down a set of stairs, one step at a time. In how many ways can Buzz Bunny start on the ground, make a sequence of 6 hops, and end up back on the ground? So notice that for this to be true, he must go up 3 ups and then 3 down. However, because this is a staircase, we know that always up has to be larger than or equal to down. Otherwise, Buzz Bunny would jump into the floor. So we start with up, since at that point he's on the ground level, so they can only go up. So once again, we can use a probability tree to display this, up or down. And so for up, now you can keep going up, or he can go down again. And then so at this point on this specific path, this bunny has jumped up 3 times already. So we know for the rest of the time it has to go downwards to fulfill these conditions. And so otherwise it could, there's no other way. So it can go up again, or it can go down. And here it just has to keep going down. And here it can keep going up. But notice that it can't go down anymore. And the reason for that is that notice at this point, it has only gone up 2 times, so it can't go down 3 times. So we keep going up, and then we reach this point where you have 3 ups, so the final move has to be down. Same logic for the other side, it's just the same. Yeah, so you can count the final number of ways, and then you notice that there are 5 different paths for which this rabbit can go up or down. So the answer is B, 5. Okay, problem 14. It tells us that there are one-way routes connecting these towns, and the distances in kilometers are marked on each route. So traveling along these routes, what is the shortest distance from A to Z in kilometers? So recall that there are some existing problems that ask you on a grid of dots and points that have distances between them, how far, what's the minimum distance from at the start to the end. So this is the same logic, except it moves it onto a graph that is irregular and has different distances across each of the nodes. So what you would do in this problem is you would find the shortest distance from here to here, and then so on for each of these until you can finally calculate onto the final ending node. So we do the same thing here as we find the shortest distance to each of the nodes within this graph. So the shortest distance to A would be 0, and to X would be 5, since there's only one path to X. And next for M, you can consider that there are 2 paths here. Either one is through 5 and 2, and one is through 8. So clearly the shortest path here would be 7. Next, you can go either from X or M to Y. And so from X, if you go from X, the path length would be 15. If you go from M, it would be 13. So we know the shortest path to Y is 13. And you do the same thing with C. Either you can go from 14 or you can go from 5. So the final shortest length is 18. And you can do the same again for the final Z. And you get 30 on top and then 28 here, or 32. So the final shortest distance would be 28. So you get the answer A, and you're able to do it relatively quickly. Problem 15. Let the letters fly bug represent distinct digits. Suppose that fly is the greatest number that satisfies the equation 8 times fly equals bug. What is the value of fly plus bug? So this problem only really gives you one condition, which is that these are distinct digits. So basically the main problem here is that if fly is too great, then it'll surpass the final 6-digit bound that is given by the bug. And so if you just try out multiplying 8 times 123, you'll end up getting 984. And that is the biggest number that can be possible to fit within the 6-digit range, 6 digits, when you multiply it by 8. So you know that the final answer is fly equals 1, 2, 3. Bug equals 984. So the answer equals 984 plus 1, 2, 3, which is 1107. So the final answer is C. Problem 16. Min enters the products 1 through 81 into the cells of 9 times 9 grid in some order. She calculates the product of each number in every row and every column. What is the least number of rows and columns that could have a product divisible by 3? So for a multiple of 3, the main condition is that you have at least one number within the product that is within like the factorized product that is a multiple of 3. So within 81, you have 27 of these multiples of 3. So basically you want to fit in 27 into some sort of shape that will like minimize the sum of the rows and columns, like the number of rows and columns. So one way you could do this is like, you can make it like a really long shape, and you would have one column and then 27 rows. But obviously that is not the best solution. So you would try and do it in a way so that it's like bunched up into like a kind of almost square shape. And so one way you could do this is if you had a square of 5, which is 25, and then you would have 2 additional numbers along some side of this. So then we can first like draw this out. So there you have 5 rows and 5 columns now, but you have 2 extra numbers, so you would just like kind of fit them on this side. So you would get like 6 rows and then 5 columns, which comes down to the final answer of 11. So the answer is D, 11. Problem 17. A chess king is said to attack all squares one step away from it. Basically like any square and next to any of its directions, horizontally, vertically, or diagonally. For instance, like a square in the center would attack all 8 other squares as shown below. Suppose a white king and a black king are placed on different squares of a 3 times 3 grid so they do not attack each other. How many ways can this be done? So basically what this means is like, okay, we could have like a white king here and a black king here, and they would not attack each other since they would not be able to reach each other. So there's a few ways you could place this. First is you place them each on a side, and first we'll label what this means. Basically these are side blocks, and then these are the corner blocks. So of course notice that we're not going to place any kings in the center because that means that the king would be able to reach anywhere. So you place on the side and the side. That would have 4 sides you can choose from. And then because each of these sides, they reach out to these 3 regions. So it means that you have to choose one of the other 3 sides to put the other king in. So that would come down to 12 possible choices on that. And then if we put it to side corner, similarly, you have 4 choices for the first person, and for the second person, since it already reaches these 2 corners, you only would have 2 other corners that you could place it at. That would be 8 choices. And then finally, corner to corner. You have 4 corners you can first choose from, and then from those 4 corners, you have 3 other corners. So that would be 12. So in total, you have the answer is 12 plus 12 plus 8 equals 32. So the final answer is E, which is 32. Problem 18. 3 concentric circles are centered at O, and they have the radii of 1, 2, and 3. Points B and C lie on the largest circle, and the region between the 2 smaller circles is shaded as well. Basically, it asks you that the shaded and unshaded regions are equal in area. What is the measure of BOC in degrees? Where BOC is this part. So what we have to do here is basically just calculate the shaded and the unshaded regions. And you know that like first we have an easy one we can calculate, which is the inner shaded circle. And so that area would be 4 pi minus pi, since they already tells you the radius, right? And then you would have the outer circle, which is 9 pi minus 4 pi times the certain like theta, angle theta, which is BOC. Yeah. Divided by 360 to get that shaded area, which is like in the fan shape. And we can equate this to the other half of the area, which is the total area of the whole thing divided by 2, and that's 9 pi divided by 2. So we can simplify that equation to get 3 pi plus 5 pi times theta divided by 360 equals 9 over 2 times pi. And so first we subtract that over, and we get 3 over 2 pi. And then we can divide this, and we get 72. So we have theta divided by 72 times pi equals 3 over 2 pi. And then divide the pi's from both sides, and we get theta equals 72 times 3 divided by 2 equals 36 times 3 equals 108. So we get the answer, which is theta equals 108 degrees. Problem 19. Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red, and the rest are white. 2/3 of the pairs are high top, and the rest are low top. The red high top sneakers make up a fraction of the collection. What is the least possible value of this fraction? So you can first convert these into the specific numbers, and so that means you would have like red, white, 9 red sneakers, and then the rest are white, so that's 6 white, 10 high top, and 5 low top. And since we want to minimize the number of sneakers that are red and high top at the same time, we would put as many high top sneakers as we can into the white area. So that would mean like you have 6 white and high top sneakers. And that means you have 4 remaining high top sneakers that must be red. So the final answer is 4 over 15. So any 3 vertices of this cube can be connected to form a triangle. How many of these triangles are equilateral and contain P as a vertex? So here we notice that we want to contain P as like our vertex. And so what you do is like to be equilateral, each of the triangles, they have to use up a diagonal of a square, since there are no other like diagonals since if you only use like the side lengths, it would not form an actual triangle. So for example, you could have like a triangle from here and from here and finally and from here, and then that would be a triangle that would be equilateral. But we want all of our triangles to be connected to the vertex P. So instead we would have a triangle that would reach from like here, and that would be a triangle that would connect with P while still being equilateral. So the same thing, we just continue to draw on these like triangles. Okay, so now you see that we've drawn out 3 different triangles here, which are the black one, the blue one, and the green one. And so these are the only 3 triangles that would actually form like an equilateral triangle, and they're all along like the diagonals of each of the squares. So we get the answer, which is D, 3. Problem 21. A group of frogs is living in a tree, and a frog turns green when it's in the shade and turns yellow when it's in the sun. Initially, the ratio of green frogs to yellow frogs was 3:1, and then 3 frogs moved into the sunny side and 5 frogs moved into the shady side. Now the ratio is 4:1. What is the difference between the number of green frogs and the number of yellow frogs now? So we can write first x to y was originally 3. Okay, so now to compare the shady side and the sunny side. So originally the shady side had x numbers, and then 3 frogs moved to the sunny side, but they gained 5 frogs to the shady side. And then the opposite for this side. So you get x plus 2 over y minus 2 equals 4. So x equals 3y, which means that 3y plus 2 over y minus 2 equals 4, and 3y plus 2 equals 4y minus 8. So y equals 10, and x equals 30. And then updated to what it's currently looking like now, we have x plus 2 equals 32, and y minus 2 equals 8. So the difference between these two groups is 24. Problem 22. A roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below. The tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? So notice here that as the tape is unrolled, the actual diameter of this tape gets smaller and smaller until eventually it would reach only about 2. So to calculate this diameter here, we would have 4 plus 2 and the average of that, and then times pi, obviously. And to find how many rows of tape you have, you would need to divide this width, which we know is 1, and divide it by the length of every tape, which is 0.015. So we get here that it's 3 pi divided by 0.015, which is 3000 pi divided by 15, which is 20 pi. And that can be rounded to 600. So we get the answer is B, which is 600. Problem 23. Rodrigo has a very large sheet of graph paper. First, he draws a line segment connecting 0,4 to 0.2020 and colors the 4 cells whose interior that the segment cuts through. And then he connects it from 2000, 3000 to 5000, 8000. And he wants to ask how many cells will we color this time. So basically we want to calculate first the slope of this, and then we can find out how within like a smaller region of that slope how much it would cut through. So the slope here is basically 5000 divided by 3000, which is 5 over 3. And so we can take this area here and draw like a small region of that slope. And so then you would have these cubes, these like squares to be covered up, which is 7 squares in total, and then divide it times 1000 again to get how within like this whole point, how much would it color. That would come down to 7000 squares in like areas that he would color. So in total the answer is C, which is 7000. Problem 24. Jean has made a piece of stained glass art in the shape of 2 mountains, as shown in the figure below. One mountain is 8 feet high, while the other is 12 feet high. Each peak forms a 90-degree angle, and the straight sides form a 45 angle to the ground. The artwork has an area of 183 square feet. The sides of the mountain meet at an intersection point near the center of the artwork, h feet above the ground. What is the value of h? So when you have 45-degree angle, it means that you have the 45, 90, 45 triangle. So you get 90 degrees and then 45, 45. So that means that this is equal sides and then a side of square root of 2 times x. So if you want to find like the ratio of the side length to this like height that you would have, it would be like x squared divided by square root of 2x, which equals to square root of 2x divided by 2. And so it means that this thing is the length of that part. So if you want to find the side length of like this area, it would basically be 8 divided by square root of 2 times, divided by 2, which equals 8 times 2 divided by square root of 2, which is 8 square root of 2. And so that means this is 8 square root of 2, and that is 12 square root of 2. So now we move on to like this area. Like what is this overlap area? If we pull down all of these down, this would be a 90-degree angle as well, and this would be 45 degrees as well. So this is 8 square root of 2. And so the total area is 183. So 8 square root of 2, the square root of 8 square root of 2 divided by 2 plus 12 square root of 2 squared divided by 2 minus this like h squared of 2 squared divided by 2 equals 183. So we get 208 minus 183 equals h squared. And that area in the middle is 25 equals 8 squared. And so we know that h has to be 5. And so the final answer is B, which is 5. Okay, problem 25. An airplane has 4 rows of seats. We have 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So the total number of ways that everybody could sit in would be 12 choose 8. Just the 8 already seated passengers. So we know that that's equal to this value. So we can cross out some of these already. And we get 99 times 5 equals 495. So now we want to find the ways in which it would not be possible for this couple to sit together. So we could have passengers like 3320, 3311, which are like the passengers already distributed among the seats, among the rows. 3221, and then 222. So this is always possible. Therefore, that means there's like 0 ways in which this would not be possible. And then there's like this many ways for them to for the other passengers to distribute them among themselves. Where the rows have only 1 passenger, the passenger has to sit in the middle. What this looks like is like you would have these seats, and then that passenger had to sit here if he wanted to block off the couple. So this is like 6 different possibilities for that. And then for the next one, you have 2 ways to arrange this group, and then that would be 12 different ways to arrange all of the total rows. But then for the groups of 2 passengers, there was 3 different ways for everybody to sit, since you can move the empty spot across each of the 3 seats. And so that would be 3 squared times 12 equals 108. Now finally it comes down to this one. It's 3 to the power of 4, which is 81. So the total number of ways that this couple could sit together would just be the sum of all those possibilities and over 495, and then subtract it from 1, which is 300 divided by 495 is 20 over 33. So the final answer to this problem is 33. And yeah, thank you all for watching, and that is the last problem for this year's problem set. Bye bye.